Hello, everyone. So we will continue our discussion about the subqueries and common table expression. Like I mentioned, common subqueries play a very important role in building some advanced scripting that can help us to handle all kind of data related scenario, whether it can be ETL related, it can be cleaning related, it can be even generating the outcome for our reporting and dashboard where we summarize the information. So all these scenarios where we need some advanced capabilities, the subquery shines really well. So in our last video, the only thing remaining was the CTE. So let's finish the common table expression, which is a form of subquery, but obviously that is separate from the way we write the subquery. And tell you the truth, CT is more like closing, more like it is closing towards the temporary table concept, where you need a temporary output based on your expression, and then that output you can use it further with the other tables or other logic that you are building. So but without wasting any time, let's jump directly into our demo environment, and we'll go straight and look how we can build a common table expression. So the syntax is we start with and then we provide the label. Obviously, our common table expression is identified by a label. So it's more like, normally once you declare a variable or once, you want to tag something, you need to give it a label, right? So it's the same way we are generating an output, and to that output, we're going to give a name, and that output is going to be recognized by that name. So at this stage, just forget what we have in here. So that's how we build the common table expression. So you can see with command, and after with, so normally the syntax is going to be with, and then obviously we have the label name, which represent the common table expression. And then after that, we have keyword s, and then why it comes under the subquery, because then you can see we put the small brackets, and under the small brackets we write any kind of SQL statement or select statement. So that select statement actually build a logic and generate the output that we can use, for further transformation, or for further logic implementation. So you can see the example underneath, and let me just put it in here, because that's all part of the syntax. Even, I'm just going to use the block comments, so it will be much better. I don't need to, in that case. I think that's a better way. Yeah, I think that's much better. And then we have the full flex select statement, which will help us to build any data outcome, and that outcome we can later on use with any other object to even generate more advanced output for the business. So let's take an example. So for example, I know that I have the duplicates in my book table. So instead of applying the logic to filter out all the duplicates and then load it into another table and use it, I have a shortcut way. I can use the common table expression, CTE, and I can generate the unique output. So you can see I'm using the distinct keyword. Distinct, what it does, it actually provide you the unique value. So all the duplicate is going to actually remove it. And in Python, we have in the data frame, we have drop a duplicate function. So it's the similar way we have the keyword in SQL that you can use to only get the unique values if you have multiple duplicates in your data set. So let me quickly run it to show you. We have altogether unique values we are getting to 32,000, right? However, if I just remove it. Let me show you in here. So just remember we have 32,125. However, if I run it without duplicate, we have 232,407. So close to 200 records we are getting as a duplicated record, right? So that's one use case. Now pay very close attention. What we are going to do, okay, we don't need the duplicate record. So what we did already filter or clean our data in the book table, and we are only getting the unique records. Now, what I'm going to do, I've already tagged it with TBL unique books, right? So the next step, as soon as my city is ready, I'm now going to write my actual statement, which is obviously, uh, let me write it down in here to just show you how things look like. I'm just going to keep it as it is, but instead of, instead of TBL, I'm going to use book rating. Just going to, and I'm going to use inner join, and you can see it is. And now instead of, you can see the SQL server already identified that we have an expression or the label that is representing some outcome that we can use into our subsequent query. So I'm just going to call it UB, and based on BR dot ISBN, I'm going to unique book. UB is more like unique books. Instead of writing the full table again and again, I'm going to use an alias to shorten the name and use that name to reflect my table. So I'm just going to now use ISBN. So the link is correct. And the only thing I need to mention where I'm reading the ISBN number, because ISBN is common between these two tables in the join. So the compiler is confused, or you can say query engine is confused, which ISBN I'm referring. I'm referring which is coming from unique books, or I'm referring which is coming from book rating, right? So that's why I need to mention the alias which where I'm actually reading the ISBN, and the rest of the column you can see I didn't need to mention because they are unique in the column list, right? So, and then just on, I just need to bring the rating as well, right? So now my query is good. Let me just run my query. So you can see I have 175 296 records. These are the records I'm doing. By the way, I'm doing the left join, so inner join, which requires both sides to be matched. It's only gonna bring those records where the instance is present on both sides of the join, right? So we have 175,000 record where the book ISBN is present in the book table as well as the book rating table, which is a shame because it is a very small record, and I can quickly show you by changing the left join, because the book rating is on our left hand side, and now look how much data we're gonna get. And like I mentioned, these are the common challenges which we have. So you can see we have plenty of null values coming into our book site. So what does it mean? It means the book information is not available, right? So we have all these book data which has been rated, but for somehow maybe it can be happen it was historically available, and then we have lost that data, like someone just archive and remove that data, and we need to bring that data. So you can see all the way in now in each lecture we are seeing how we are unfolding the facts which are hidden, and how the SQL commands, they will help us to unfold these facts, right? And one more thing, you always remember that most of the time we heard about, data always tell us the story. So these are the story, like you can see that majority of the books which are sitting in the book rating table, they don't have the corresponding instance in the book information system, right? So that will actually help us to go and find out what's the reason and how we can fix it, right? And that's how we start improving the data asset within the organization. So we have altogether 1.14 million record. And out of those, only 175 records have their instance present into the book. So there, in this short video, we have seen how we can use CTE. You can put any logic within the city boundary, and that will, once it execute, it will turn it into a temporary data set that you can further use to generate even the more complex outcome based on the business logic that has been given to you. So that's how we use CTE. There are alternates available as well. Obviously, once we're gonna actually reach to that point, we're gonna discuss this alternate. So hopefully the CTE makes sense, and just give you one teaser that these lot of nulls and the books that we are not getting, we'll see how we can recommend the title, or how we can recommend the values based on the available data. I know it's not going to be very accurate, but that's where you're going to see how machine learning shines, and how we can use machine learning techniques, especially the recommendation, to recommend the gaps if they are sitting into our data set and nobody has any clue, and we want to fill it up based on some intelligence logic. So hopefully this video will be beneficial for you. You enjoy the video. And what I'm gonna do next, we are going to do the same thing within the Databricks. Guess what? We're gonna use the big data SQL to see everything that we have done in here in action, and then we move towards the analytical function, especially the aggregative function at this stage, and then later on we go towards the window function, which will cover one of the major milestone of this series, and then we will come towards the T-SQL part of the data engineering side. So stay tuned for these videos. Thanks for watching, and I'll see you in the next video.